Now the next part of this module is going to consider some important applications of quadratic functions, and these would be two applications that we call optimization problems. And in these kinds of problems we're going to want to find either the maximum of something or the minimum of something. So for our first example, we're going to look at this situation. We're told that we have a baseball that's thrown upward with an initial velocity of 70 feet per second. Its height h in feet is given by the function, which you can see highlighted in blue here. H is equal to negative 16t squared plus 70t plus 5, where t is the time and it's measured in seconds since the ball was launched. So we have two questions to answer. First, when will the ball reach its greatest height? And what is that greatest height? Now I think you'll agree with me that the graph of this quadratic function is going to be a parabola that would open down. So therefore it should seem reasonable then that what we want to find to answer these questions will be the vertex of the parabola, because the y value, which in this case is an h value, will give us the maximum value of the function, which will then be the maximum height. So let's next then find the vertex, and we're going to use the formula that we encountered a bit earlier in the module, where we can find the x-coordinate using the formula negative b over 2a. So to find the x-coordinate of the vertex, which for us will be a t value, we'll write next then a t is equal to negative b over 2a, and we substitute those values in from the function. So our b value is 70, so we have the negative 70 all over 2 times our a value of negative 16. That will become the negative 70 over negative 32, 70 over 32, and then it's a decimal that will simplify to 2.1875. Now to find the maximum height then, which will be in essence the y-coordinate of the vertex, we're going to substitute that value into the function. So h then will be equal to negative 16 times 2.1875 squared plus 70 times 2.1875, then plus 5. And if we simplify that, the result turns out to be 81.5625. And what we'll do then to end up is to write a sentence answering the questions posed by the problem. So we'll state then that the ball reaches its maximum height of 81.5625 feet after 2.1875 seconds.